Today a laptop motherboard has arrived, Acer Predator 300 series, which part number is LA-F952P from the keyboard, whether it is getting triggered or not. So when triggering, I'm not getting any response. Hello everyone, welcome to Service Planet. Today after a long time I am making a case study again. Today a laptop motherboard has arrived, Acer Predator 300 series, which part number is LA-F952P. This I got in dead condition, and from today onwards we'll try to continue the case study, and the case study will be made in two languages. One will be in Hindi, which will be in my voice, and the other will be in English, which will be in Siraj's voice. Siraj, say hi. And today all the team members of IT Service World are present here, Avijit and Sohel. One is in vacation. Later I will introduce him to all of you some other day. So let's start today's case study. I will connect the DC jack first. And the most famous trick of AFS solution is the 30 millisecond trick. Let us see what is the issue using that trick. 191, 194. So here in 30 milliseconds it is telling me that there is a major short at some place, because it is showing in 3 digits. Once I turn on the power, I will see that here 178, 172 is staying in 3 digits. Even pressing the power button, there is no response because it is stuck in 3 digits. This is the power button here. There is no response even when we press the power button or short the power button. So we'll directly go into testing now. So first we'll check the impedance if there is any shorting or burn on the motherboard. We'll find a short somewhere in this. First of all, I'll check the impedance of all the coils in the board, and you can see in the microscope that if any part or something is burned, you can see easily. There is 424 ohms here. This is healthy. This is near the battery terminal, which is 122 ohms. In the battery terminal it should be 3 digits high. That is not healthy. This is 29 ohms. $319 ohms. Okay, this is fine. Here 476 ohms. Okay. 1.2 ohms. This is for the graphics coil, which generally comes in this value. There is no shorting in this. 1.2 ohms. This is okay. There is one coil over here, 102 ohms. This is also fine. Now let's go to CPU section. 26 ohms, 3.7 ohms. This is in series, so it will show same value as the other because it is directly connected in series. See, its output is connected directly with one another. This will show different value because it is not connected in 8.3. So here the problem is suspected to be found at 2 places. One, this is 29 ohms, and the one here at the battery terminal is 122 ohms. So let's go over its schematics once and see which is these 2 coils. Let's see how much value it will have. I got the lowest value on this coil. Let's look at PL602. PL602 is 1.05 volt. It's going to PCH, so the value shown in this is common, meaning there is no fault in it. The value shown here is 21 ohms, which means the PCH is also correct. The second one I got here is PL301. There is no need to look at it. This is its output, CLR with output From the CLR it goes to the battery terminal, meaning this is the output section of the battery. So the little value here is not healthy. Now we will look at this section, because the value we are getting from DC reading is 177, which means that it is getting heated at some place or the other. If you measure its heat manually, then it is getting heated in this section. I will also check this section once with a thermal camera to see how much heating it has. Once I power up the motherboard, so you can see here 67, 68, 69 degrees Celsius. It is reaching 74, 75, means it's getting too much hot. This is the charging IC which has been used here. It is so from a very basic way. First of all, let me check whether there is any shorting happening in all the capacitors around this IC or not. Okay, fine. These capacitors are fine. There is no short over here. So there are two charging MOSFETs on the opposite side. Here it is, opposite side of the board. This is showing 122 in the impedance. So first of all, we will use the basic steps on this. In this charging IC, I find that grounding pad below is dry in many places, in many cases, due to which this problem can also occur. So first of all, we will restore the grounding pad of this IC, because in many cases I got the same problem in most of the motherboard. Okay, the grounding pad is restored. Now let's turn on the motherboard using the DC, whether there is some changes or not. Let me power it on. The reading is a little bit decreased here, but there is no changes. It is in 3 digits. It will not power on. I want 2-digit low here. Until and unless I get 2 digit, it will not power on. Let me power it on by shorting the power switch. There is no response on power on. So until I get to 2 digits here, I will not go to any other section, because I have found a fault here. So I will not check any other section right now. So first of all, let me change this charging IC and see. Its IC number is 88739A. Here is the donor board. I will swap the IC over from this donor board. Okay, this is done. The IC replacement is done. Now let me check its DC reading once. Now you can see that the 2 digits that I wanted are coming here. After this, it is going into sleep mode very quickly. There is no problem with this. Let me trigger it once and see. So when triggering, I'm not getting any response. Let me see if this is the switch or not. So actually we were considering this SW2 as a power switch, but this is not a power switch. Here's SW2. SW2 is written below release, battery off, push battery on, meaning if you install a switch here, you can turn the battery connection on and off. And SW3 is the reset button. SW3 are not present here on the board. We'll get it on SW1. After looking carefully, we found that this on off button is connected with the keyboard controller, because it is in the keyboard button. So now I will turn on the power and check from the keyboard whether it is getting triggered or not. So let's turn on the power, and we will turn it on once with the multimeter and check it in diode mode. It's also triggering, and the ampere consumption is around 1 ampere because there's no RAM connected. So once I install the RAM, let me check its display also. So I connected the RAM to it. Let me try triggering it once and also connected the screen with it. I ground the red probe on the ground, and with black probe I short. Yes, a trigger is happening. It remains to be seen whether the display will be available here or not. Ampere consumption is also good. Let's change the RAM once and see if the display comes or not. Yes, the ampere consumption it restarted. This restart happened right now. It was not taking last time due to RAM. It is possible that the display may come on now. A restart is necessary once it is turned on because the battery is disconnected. Now you can see that the Predator logo has also appeared here. It is unbootable device, meaning this case is solved. Due to charging IC, it was damaged and it was fully dead. So this is a simple case study. We will make more in future, and this case study, whatever knowledge I have shared with you, all is due to AFS solution, Rafi sir. I have just shown you a glimpse. Thank you so much for watching. Have a nice day.